Shh. All right, so we've got a graph which has this rule. Y equals A times root x take x. Sorry, do you guys want to come up and do it? You want to come up and do it? Pass us through the points 1, 2, and 10, 4. 10, 4, good buddies. Find the values of A and H. Well, you've got letters all over the shop. However, you've also got two really good bits of information here. Right? You've got that 1, 2. Check 1, 2, check. That is your x, and this is your y. So how about we sub that into our equation? So we've got y equals A root x take h. Let's sub it. We've got nothing else to do. Sub away. 2 equals A 1 minus h. We okay with that? All right. You go, well, that's that done. What else could we do with that? Not much. Let's now try the other point. 10, 4. Let's sub that into the same equation. Not a different equation, the same equation. That's my x, that's my y. Have you done this, chaps? Did you? Well done. Good chaps. So, okay, we've got this. I know how I would do it. What we basically want to solve for A and H. What do we see there? I see that. Yes, Raz. Right, so to get rid of the square root, we squared. That might be a better, like I've got that in my head. I've got two options. One, to do that. Square both sides to get rid of the square root. The other is that could I rearrange one of these to get A by itself and sub? Right? Both methods sensible. So hang on. Yeah, you could rearrange both and have A equals and then make them equal each other. You could just rearrange one and sub one into the other. You could square to get rid of, and you'd still have to, yes. Yeah, I was about to say, so those people who have done, normally when we've done sequences and series first in spec, you could also divide. And that cancels out a whole lot of hoopla, but you'd find we get to the same thing as if we subbed, right? So let's just show you what we mean by that, and it's really nice to see the different options. So we'll start with that one. Does everyone understand what he's saying there? Where he's divided. So if you divide 2a root 1 take h, 4 divided by 2 is? The a's now cancel out. We've still got, it's up to you, you can keep them separate. Remember the rule about square roots with division? When you've got root a on b, that is the same as root a. So we've got this separate. We can actually make it all in one if you wanted to. So that is, yeah. So 10 take h over 1 take h. And now to get rid of this square root, we square it. So we end up with 4 equals 10 take h over 1 minus h. And you can now cross multiply and solve. You could also, what we're talking about, that's what I'm talking about. If I take this one here, and we say a equals 4 over, so I'm taking this, I'm trying to get a by itself. Would you agree it's 4 over root 10 take h? And we sub that, no. So did you get this where we divided? Tom did. We're just saying other people looked at it differently. You could also, I'm just taking this simple equation here, that's an a times. Let's isolate a. Get a by itself. It means 4 on the other side. To get rid of this times root, whatever we divide by. Happy with that? And what I can now do is substitute this in place of a here. So you end up with 2 equals 4 over root 10 take h, and you've still got this 1 take h, and you get the same thing because you'll divide and square root, square, same bizzo. If I had rearranged this to have a by itself, I would have ended up with exactly this thing here. Just substitute. Well, you frown. We should be able to go either way. Like when I say, well, ideally, yes, you should be able to manipulate both ways. When we say you can substitute, you can simultaneous, you can divide, it's all the same. We can square. Doesn't mean you have to do each method. No, do what works for you. But sometimes that one won't work. Yes? There's no hard and fast rules to say you must use this method in this case. Because sometimes what that a might be, it might not be a single a there. It might be an a take 2. Then substitution would be your go. So if I had one here that's got an a by itself and that had an a take 2, substitution would always work. No, you just have to do different questions, so you'll be right. Don't panic too much. If you got the whole subbing in and trying to solve, that's fantastic. What's the matter? This? I just answered that with Costa a minute ago, so I really need you guys to listen the first time. Here, I'm trying to get a by itself. That's a times that square root, yeah? So how do I get rid of times square root? Third time I've explained it, but that's okay. I'm very patient. Very patient. All right. You can keep going. You don't have to do. Which one? Oh, ask me again. Don't do that. All right. Notes. Circle. I was so rocking the circles last lesson. It's not funny. Circles, very simple. This is our fundamental rule that we have. Seen it before? Okay. Some have, some haven't. That's all right. That's good. If you haven't, it's not rocket science here. Trust us that this is how it goes. That's your general form of a circle. When it is in that form, it's really nice. You can get the center and you can get the radius. Okay? So here, as an example, I've got this. That would mean my center of the circle is 3. -5. And my radius, Nishan, is 7 because it's the square root of this. This is r squared, right? It's the square root of that. Yes, because this is r squared. This is r squared, and when you square root it, that's what you're doing. You're getting 7. Right? Because when it's x take a, it's a. When it's y take b, it becomes positive b. So x take 3, you get positive 3. Y plus 5, you get minus 5. Them's the way the rules work. The C is C for center. Right? And when you say that confuses me, I go, no, hang on. It's attached to when we do horizontal translations. When we shift something and we've got when we go x take 4, we know squared with a quadratic, we know that that actually moves it to the right. You're very whingy. I'm just kidding. I'm just kidding. Raz, you're right? All good? So I can keep giving you lots and lots of these and you'll find that they do. You can go the other way. And I seriously am getting sick and tired of talking over people, so shush. You can go the other way. If I tell you the centre of a circle is -1, 4, and it has a radius of 3, you should then be able to tell me the equation of a circle. What would that be? Ish. Yep. Bang, done. And I would leave it like that unless it said put it in expanded form. Leave it. Don't do more than what you are needed to. Yes? So, straightforward. Bang, following that theorem, that rule, the general form of a circle. It doesn't get much easier than that. So we've got this problem now where I'm not saying here's the centre, here's the radius. You actually have to find it, right? It touches the x-intercept. That means you cannot do this because that is cutting the x-intercept. Okay? So for it to touch, it has to look like this. Now, are you still convinced the radius is 7? And we're not going to say the radius is -3. It's the length. It's 3. So that means our radius is 3. But we didn't have to guess. We didn't have to go, I don't know, is it this, is it that? We drew a diagram and it solved it. Bang, straight away. Obviously, what would happen if I said it touches the y-axis? That would then be 7. Capiche? So that now becomes x take 7 squared plus, thank you, y plus 3 squared equals 9. Okay, so it's all about that mystery of can you find the centre, can you find the y-intercept? Okay, yo. Of course not. Yes, we're getting there. Yes. One of the tricks I have up my sleeve to not give you the centre and make you find it. Anyone? I've actually done questions like that already when we did lines. Not pass through the point. So Costa, again, you want to talk, get out. Because if you ask me the same question that I've just talked about once more, that is it. That's Costa. It's on video. So this is where I haven't given you the radius and you had to draw a picture and work it out. Can you think of when I might not have given you the centre of a circle and yet you had to work it out? Midpoint. Yeah. So I could give you 2 points on the outside, right? I could give you, these are the things of the diameter. And find the centre, you would have to use the midpoint. How would you find the radius? So you could do the diameter and halve it. Here's another thing for you to think of and get back to that question. So we've got centre 8, 3, and passes through. Give us a point. I'm on fire today. 4, 7. So we already know that we've got x minus 8 squared plus y take 3 squared equals the radius squared. How could we work that out? I hear distance. Could work out the distance. Absolutely. Yep. I would do that. I would sub. That's my x, that's my y. And because it lies in the circle, when I sub it, it will actually equal my radius. I know. Groovy. Ha, ha, ha. Let's do that. Equals radius squared. So that would become 4 take 8 squared plus 7 take 3 squared equals the radius squared. I know I'm doing this quickly, but it's because you get to then on Monday just go through stuff, okay? And since my other video was whack, I now need to make sure. Oh, I think it was. No, that was probably me. I stop, I start. No, I stop and I start, so you don't have to listen to me or watch me move things. Anyway. If, let's say out here, this point out here, if I sub that into that equation, what value would I expect over here? Out here, is it on the circle? So when I sub it in relation to 32, you should be expecting a larger or smaller number. Yep. If you had one that was inside the circle, smaller circle. Okay? Great questions in some of the books where they talk about you might have a phone tower here and you've got the radius of reception. If someone is, at this coordinate, that coordinate, will they get phone reception? You can work that out quite easily. So all pretty simple so far. Happy? Doable? The bit that you're not going to like is find the, oh wait, I get carried away. Find the center and the radius of that. So in other words, what I need you to do is put it into this form. It is really, really nice if you remember how to complete the square. What do you mean by that? That's a nice response. What do you mean by that? What I mean by that is, Spence, you're looking tuned in there. You have, sorry, boring you to death. I apologise. X plus 4. No. Yes. X plus 4 all squared. What is that expanded? X squared plus 8x plus 16. This is what we call a perfect square. Yes? Yes? Well, it's a square. Alright? I say perfect, I just like things perfect. What if I had x, give us another value? I'm running out of numbers. I mean, I've got so many to choose from. Take 8. That would be right. If you haven't tuned in, remember when you expand the squares, you double and you so if I now had this, would you be able to tell me what would have to go here and what would have to go here? Finn? Sorry? 25. Why? Why? Half of that is minus 5. You square it. And therefore, would you agree minus 5 is there? Agreed? Do one more. How about x squared plus... Okay. We've already done 10. Play along. I'm going to leave 2 for the moment. So you say 7. Where am I putting? So that becomes 7 squared, right? So 49. And this would become? We all good? So if you wanted to, you could say you're doing this 14 over 2 squared. Well, that's what you're doing. You're halving it. So this is if you now want to look at it next lesson and you think, oh, I forgot what they were going on about. You could have this in your notes, and that's what you go back and look. Those who go, know it like the back of my hand, you don't need to. Yes? So what you're going to do now is I want you to apply that to this. And we go, well, look at this for starters. When you see the x plus 6x, straight away you should be going, well, easy. That is x plus 3 all squared. However, to make it x plus 3 squared, when I expand x plus 3, I get the x squared. I get the 6x. Woo! But what else do I get? I've added a 9. By writing this like this, haven't I added a 9? So, if I add a 9 to this side, add 9 to the other side. Now, careful, don't get too excited. It's y take 9 squared, and again, when I put it like that, when I put it like this, when I expand this, I get the y squared. Woo! I get the minus 18y. Woo! What else have I done? I have added 81 to this side, because minus 9 squared, look at them all. They were all positives, right? I have added 81 to that side. Now that's okay, as long as I add. Make sense? Because I want to get it into this form so I can then say, ha, 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 here's your center, here's your radius. So this now becomes x plus 3 squared plus y take 9 squared equals, what's that? Minus 71 plus... And therefore, the center is minus 3, 9, and my radius is root 80. And I wouldn't leave it like that, because is there a square number that goes into 80? What is that square number? Well, it's hurting my head today, right? I'm tired, and I do know that it is 4 times 20. Oops. Oh, that's no good. 4 times 20, which becomes 2 root 20, but then I go, well, hang on. 20 can also go again with 4 5s. So that's actually 2 times root 5, so it's 4 root 5. And I go, oh yeah, of course. That meant 60 went into 80, but I didn't know that. So I broke it down. Yeah. You could just type it into your graphics calculator. Yep. You never need to... Right, hello, looking at this one. Okay, once you've done one of these and you get into the pattern, Dion, right, it's the same thing over and over. So we look and I go, right, looking here, right, I'm going to halve this little sucker. So I've got x squared plus, oh, why did I say squared? So once again, I've got chat. What did we do back here to go from here to here? Right? From here to here and so on. We divided by 2. So I'm dividing by 2. I'm not going to put 3.5 because we're big people now and we can write a fraction. It scares all the other little people. Now, the 3 is still on the other side, but when I expand this, yes, I get the x squared. Yes, I get double this, which is 7x. But won't I also get this squared? Because, once again, you told me very confidently back here that when you expand this, this is the 4 squared. This was the... and so on. We. So, I have to add on 7 over 2 squared. happens? Y. You halve it. And again, when I expand this, I'll get the y squared. I'll get the minus 2y. I also get this thing squared. What's minus 1 squared? So I've technically added 1 to this side. I must add 1 to this side. Now, again, you could go to your fractions, but your calculator, each and every one of you should be able to confidently yell out what 7 over 2 squared is. Right, you square the top, you square the bottom. 49 over 4. X plus 7 over 2. And feel free to share with me. So I would do this. That's 49 over 2. Now I have to add the 3 and the 1. Now that's 4. Right? I have to add it onto this. Sometimes I convert this to a mixed fraction, but in this case, 3 plus 1 is 4. Would you agree that that's 8 over 2? 4! Because they're talking. I'll blame them again. Square the top and the bottom. 49 over 4. Right? It was 4 all along. 3 plus 1 is 4. That would be 16 over 4. And now I can just add the topsies. Right. So 3. Hello, lovely ones. 3. They're all yelling, by the way, if you can't hear that on the video. They're going, why is it 16? But what? Right, so 3 plus 1 is 4. And what we're trying to do is go 4 plus 49 over 4. Now, we said you've got 2 options, right? We all think differently. You could write this as a mixed fraction and go 4 into that goes how many times? And so what's that? That's going to be 4 into there goes once, into there goes twice, and 1 left over. Right? Then add it to the 4. I'm not a fan. I want to put this as so many quarters. How many quarters in 4 holes? And even you should look at this before you go, how did you get 16? 16 divided by 4 is 4. And we just said 3 plus 1, right? Calm. 16. And so the benefit of that is now I can go 40, 50, that's 65 over 4. No, because that's it. Well, is there a number that goes into both of those? I cannot think of one. And so therefore my centre is minus 7 over 2, positive 1, and my radius would be root 65 over 2. Before you all yell out, why 2? Stop and think. You square the top, you square the bottom, square root of 4 is 2. So we just got a last minute request with 4E, question 4. Rectangular hyperbole of this form. Now, what we know about this, right, if we had something of y equals, let's go 3 over x, take 7 plus 1, we know that this gives me my horizontal asymptote. This gives me my vertical asymptote. It would be x equals 7. Do you agree? Alright, so because this now says it's got a vertical asymptote of 2, I know that that's going to be underneath here. That has to be x take 2. Do you agree? If it was x take 7, x equals 7, because your vertical asymptote is when the denominator equals 0. So for it to be 2, then x take 2 must be the factor. And it's got a horizontal asymptote minus 4. That means I know it's in take 4. Right? And y equals, and we can keep the a. Now when it passes through this point, 0, 4, sub it in. And you should be able to, you'd be left with finding a. Does that make sense?